Okay, we're back. The example problem here has $10, sorry, 10 $1 bills, 4 $5 bills, and 1 $20 bill. Would you pay $1 to be able to grab a bill out of the wallet?
Yeah.
Yes. Would you pay $15 to play this game? Nah, probably wouldn't be worth it. Okay, but somewhere in between is a fair price that would be exactly the fair amount. That's what expected value helps you to figure out. And it has P times A and then add them all up. Well, I got to figure out the probability of getting a 1 and then multiply by the amount I get if I get a 1, which is 1. And then do that for the 5s and then do that for the $20 bill. Would you please figure out P times A for all of those and then add them all up? I'll pause while you do that. Grand total, when I add all of these up, P times A and P times A and P times A, I get, let's see, these two together would make $2 plus the $1.33 here makes $3.33. So, somebody charges you to play this game. They charge $3.33. Then it's hard to say whether you should play or not because it's exactly a fair price. But you're not going to like win or lose over time. All right, one of the weird things about expected value is that this is a value that you would never actually get, right? You're either going to get 1 or 5 or 20. So this is kind of weird, but don't expect to get the expected value, right? So over time, though, if we played this a whole bunch of games, that's the average of what you would win. You get that? If I played it like 50 times, I add up all the money I got and divide it by 50. It's like an average amount. That's what expected value is. All right, let's look at another expected value scenario. Here's one of those spinners, and same kind of a deal. Would you pay $1 to play the spinner game on the left? Yeah, that'd be a no-brainer. I'd play that all day long because you'd never lose. Because worst case is you get your buck back. And if it was $20, I'd be an idiot to play the game, right? But somewhere in between is a fair amount. Just take a guess. Don't actually calculate it. Just take a guess. It seems like I bought a fair amount. And write it on your paper. What do you think is the fair amount, the expected value? Write it down. No calculating. Just gut feeling. All right. How many of you wrote something that's less than $3? How about between $3 and $6? How about between $6 and $10? Oh, almost everybody's in there. All right, now let's calculate it really quick. Use your calculator, and this one's easy because they're all 1/3 times, see P times A? They're all, probability is all 1/3. So 1/3 times this, 1/3 times that, 1/3 times that. A third of a buck is 33 cents. A third of $20 starts to add up, though. A third of $20 would be 20 divided by 3, $6.67. And then a third of $5. So 5/3 is like 1 2/3. It's $1.67. 7, 8, about $8.67. Is that right? And most of you guys were right on your gut feeling. That's good. All right. Moving on. All this slide is meant to be is a reminder of that the amount, the expected value you get is kind of like an average value because you're not going to actually win that amount. Just over time, it'll average to the expected value. All right, you know I'm obsessed with Macs. Still I'm trying to decide do I buy it or not. The only problem is it's twice as expensive as the other computers, but they're really cool. So is it worth it or not? I don't know. Now the thing that's bothering me is this new tablet that they're coming out with is supposed to have like a touch screen that's fairly big. It's like the cross between an iPhone, which is the small touch sensitive screen, and a laptop. It's like right in between those two. And it's got a touch sensitive screen that's fairly big. So what do you think I'm thinking about whether I should buy one of these or not? Wait, because why? Price will go down because why? Because they'll come up with something better like what? a touch screen on this. Why not? The whole giant screen could be a touch screen, and that could be what's coming next. They already have them for PCs, but they don't have them yet for the Apple Macs. Don't have a touch screen yet. So anyway, especially since they're coming out with something in between that's touch screen, the next step is probably to make this touch screen. So I don't know. Maybe I'll wait till that comes out. Okay. Yeah, it's an advertisement for Star Trek on there. It was a good movie. The next thing is if I buy one, I'm looking for whether or not I want to get this warranty. This is a typical problem from our test also. It's a probability question really, because there's two things that could happen. It's like a tree. It either works for 3 years or it breaks sometimes in that 3 years. So what's the probability? I don't know. That's the hard part. What's the amount that I get? That I can figure out. I'd like you to help me figure out what the probability should be. What do you think, if you were to buy this new computer, what do you think are the chances that it's going to go for 3 years, that it'll break sometime during those 3 years? 1 out of 3, 1 out of 4, you think half? Okay. 1 in 10. I'm getting a wide range, and that's exactly why it's hard to figure out whether to get this or not. Because if I knew it was going to break, well, duh, $169, I can get a whole new $2,000 computer. If I knew it's going to break, of course I'd buy it. If I knew it wasn't going to break, duh, I don't want to waste my $169. So it's a tough decision because of that percent. All right, I'm going to give you an amount to use that I think is somewhat reasonable. I want you to figure it out at 25% chance that it breaks. All right, see if you can figure out your expected value. I will pause while you, yes, it's a $2,000 computer, and the Apple Care is $169 to protect your $2,000 computer. I'll pause while you do that. Okay, in the interest of time, I'm going to do this one myself and show you it's 75% chance it works, 25% chance it breaks. The amount I get if it works, well, I don't really get anything. In fact, I lose $169 because I spent the money on a warranty that I didn't need. If it breaks, though, I'll be very happy because I'll gain the $2,000 minus the $169, which comes out to $1,831 if I multiply these out. Okay, there's my amounts, and then if I add them together, my grand total, 331 even. All right, so that's not just saying that it's a good deal. That's saying it's a great deal for the warranty. Because if it had come out to 0, then that would have meant it was a fair price. In this scenario, we included the cost of the warranty. So if we'd have come out to a 0 balance here, this would have been okay to be a 0. It would have been fair. This is way better than fair. I'd make tons of money. And this is a real world example. Only number that I picked was the 25% chance that it breaks. So you can tell that Apple is betting that there won't be a 25% chance it breaks, because they don't want to be giving away the warranty this cheaply, if so. So they're betting it's probably only 1 in 10 of them will break. And if we do the numbers with 1 in 10 instead of 25%, then it's going to be closer to a break even. Okay, so that's a warranty problem. Do you understand what I'm talking about there? All right. Then our next type of question is this. This is a contingency table. These are really easy. Let's say that I said I picked one of these kids and I asked them if I was going to give them a free Mac or a free PC. How many of them, what's the probability I would pick a kid who wants a Mac? Well, I'd look for, there's 135 kids that wanted a Mac. Out of 480 total, 135 out of 480. If I do a given, though, given that the kid is a junior, then that changes everything, doesn't it? Given that the kid's a junior, I only look at this, and now my given especially changes the denominator. Can't be out of 480 more, and also out of 120. And now it's people at like Max right here, 30 out of 120. So remember that given will change the denominator on those. Those are pretty easy. And now the last kind of problem. Pizza questions, just going to briefly touch on these. You remember how these are C's versus P's? C being combination, P being permutation. Which of those two does the order matter, the C or the P? The P, you're right. So I'm using C because the order doesn't matter. If I get a pizza that has sausage and then pepperoni, or pepperoni and then sausage, the order doesn't matter. So all you'd have to do is say there's 16 toppings here, choosing 2 of them, or 16, choosing 3 of them. That's all there is to it. That's all the time we have for today.